Hello everyone. So today we're going to look some more at graphing quadratic functions, sharing everything right now. So there are many ways in which you can start this. You don't have to follow the steps exactly, but it really helps if we follow these steps when graphing quadratic functions. So in order to graph a quadratic function without a calculator, we need to find key points as in the axis of symmetry, the vertex, and the y-intercept. So first we're going to find the axis of symmetry. Remember to find the axis of symmetry. It's x equals negative b over 2a. So first we're going to identify our a, b, and c. My a is 1 because there's nothing in front of x squared, so we assume a 1 is there. My b is negative 4, and my c is negative 5. So it's negative 4 or positive 4 over 2 times 1, because a is 1, which gives me 4 over 2, which gives me 2. So my axis of symmetry is at x equals 2. Now I can go in and draw that axis of symmetry. Remember, it's a dotted line if I want to, knowing that everything's going to be symmetrical about that line. Now to find the vertex, I'm going to plug 2 in to my equation. So y equals 2 squared minus 4 times 2 minus 5. 2 squared is 4 minus 8 minus 5. So 4 minus 8 is negative 4. Negative 4 minus 5 is negative 9. So I get that my vertex is 2, negative 9. So we're going to put a point at 2, negative 9. It should be right here. Next, we're going to plot our y-intercept. Our y-intercept is at 0, negative 5. So 0, 1, 2, 3, 4, 5. Negative 5. So 0, negative 5. Now, it says find 1 to 2 other points on the same side of the axis of symmetry as your y-intercept. So I know that this is 0, and there's going to be a number in between here at 1. So I'm going to plug a 1 in. And I'm going to do y equals 1 squared minus 4 times 1 minus 5. 1 squared is 1. 4 times 1, negative 4 times 1 is negative 4. So 1 minus 4 is negative 3. Negative 3 minus 5 is negative 8. So I get 1, negative 8. And you can do another point if you want to. It's really up to you, but if we were going to do another point, I'd do negative 1. So y equals negative 1 squared minus 4 times negative 1 minus 5. Negative 1 squared is 1. Negative 4 times negative 1 is a positive 4. So 1 plus 4 is 5. 5 minus 5 is 0. So we get negative 1, 0. Now, the cool thing about the axis of symmetry is you can use the axis of symmetry as a line of reflection to fill in points from one side of the parabola to the other. So this is an axis of symmetry. So since there's a point here, there needs to be a point here. It's 1 unit away right there. This is 2 units away, so 2 units away right here needs to be a point. 3 units, 1, 2, 3 units. And now we have a symmetrical parabola. Draw your line. And there you go. And the way I chose 1 and negative 1, when they were around my y-intercept. It just helped to choose those points. All right, for the next one, let's find the axis of symmetry. So x equals, going through here, it's negative b. Let's first identify a, b, and c. A is 1, b is negative 6, c is 9. So negative 6 is a positive 6 over 2 times 1, which gives me 6 divided by 2, which is 3. So now I'm going to plug 3 in, and I get 3 squared minus 6 times 3 plus 9. 3 squared is 9. 9 plus, so I'll do this out for you guys. This is 6 times 3 is 18 plus 9. We get y equals 9 plus 9 is 18. 18 minus 18 is 0. So my point is at 3, 0. So I can start with that point at 3, 0. And that's my vertex. So I have, remember, an imaginary line right there. And then the y-intercept is at 0, 9. 9. And then before I even do the other points, I know that there is another point right here because they're symmetrical about that axis of symmetry. Let's find some other points. So I'm going to do the numbers between 0 and 3, so 1 and 2. So we're going to plug 1 in, and I'm going to plug 2 in. Okay, so 1 squared is 1 minus 6, because this is 6. 1 minus 6 is negative 5. Negative 5 plus 9 is a 4. So we should have 1, 4, which means I should also have 5, 4, because, again, symmetrical. And for here, I get 2 times 2 is 4. 4 plus 9 is 13. This gives me negative 12. 13 minus 12 is 1. So I would get 2, 1. But on the other side, I would also get 4, 1. Remember, symmetrical. Draw your line. And again, this is only if you don't have Desmos and you are strictly using your brain to figure all this out. Okay. Let's look at a couple of quadratic word problems. We're definitely going to come back to doing this in just a second, but let's look at some quadratic word problems. The height of a soccer ball kicked can be modeled by the function y equals negative 16x squared plus 64x. And I'm going to be real. Think about if you kick a soccer ball or a football or anything, this is going to model a motion like this. So when that models that kind of motion, we're going to have a negative in front because it needs to be concave down. Where x is the time in seconds, this is a very common problem you're going to see. How long is a soccer ball in the air? What was the soccer ball's maximum height? How long did it take the soccer ball to get to the max height? What would be the important parts of the parabola to find? Why? So first of all, I need the maximum. The maximum is also known as our vertex. So I'm going to need to know the vertex and the axis of symmetry to be able to find this. So let's find the axis of symmetry first. So my A is negative 16, my B is 64, and I don't have a C. It's at 0, 0. Because when you're kicking something, it's starting on the ground, which has no height. So if we want any, we can plot that right away. So let's first find our axis of symmetry. So it's negative 64 over 2 times negative 16. This is negative 64 over negative 32. That would give us a positive 2. So 2 seconds. Because remember, x equals 2. Now we're going to plug that back in to solve. So we get y equals negative 16 times 2 squared plus 64 times 2. This is me finding the vertex. 2 squared is 4. 4 times negative 16 is negative 64. 64 times 2 is 128. And so I get that y equals 64. And my vertex is at 2, 64. So let's plot that. Now each of these are going to not be worth 1 because I wouldn't be able to plot that. Let's go by 8s because that's going to help us at least going up. We have 8, 16, 24, 32, 40, 48, 56, 64. So if we get up to 64, the other ones are going to be, the x-axis is going to be counting by ones, but we go to 2, 64. Now remember, this is our y-intercept, or our 0, 0. So it's 2 places away from our axis of symmetry, which means the other time is right here. And we have this function right there. That's the track that the ball took in height. It might have gone straight up and down, but that's the height it did over time. Now, we found the vertex. What does this vertex mean? Let's see the questions that we have. So first of all, how long is a soccer ball in the air? Well, it's in the air from here to here. This is 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, because it starts on the ground here and it ends on the ground here. So in the air for 4 seconds. That's the first question. Next one, what was the soccer ball's maximum height? Well, we're looking at these, and remember, our x is our time, and our y is usually going to be our height or our distance. So the max height is 64. I'm seeing if they have a unit here. It doesn't look like they have a unit. So let's say this is in feet. So the max height is 64 feet. Okay? So what told us that maximum height? Well, the vertex did. So vertex told us max. And what told us how long it was in the air? The zeros, or the x-intercepts. Zeros told us air time. And then the third question is, how long did it take the soccer ball to get to the max height? Well, it took 2 seconds for it to get to the max height. It took 2 seconds to get to max height, because 2 is the x of the vertex. You could say either the vertex or the axis of symmetry told us that 2 seconds. Okay, let's try another one of these. The height in feet of a golf ball that is hit from the ground can be modeled by the equation -16x squared plus 96x. Looks very similar. The reason we're always going to have -16 here is that that is acceleration due to gravity. So that takes into account your gravity. Where x has been time in seconds after the ball was hit. What is the golf ball's max height? How long does it take to reach the max height? And how long does it take for the ball to reach the ground? Okay, so a couple of things we need to know here is we're going to also be doing, it tells us that this is in feet, and we're going to be finding out the same answers as above. So let's start with finding the axis of symmetry. So x equals -b over 2a. Let's find our a, b, and our c. So the a is -16, the b is 96, and our c is 0. Our c normally is going to be 0 unless like you're starting from the top of a, I'm trying to think. Sometimes you start from like the top of a tower when you're doing this, or like a cliff. So we're going to put our point at 0, 0. Here we're also going to be counting by, trying to think what might be easiest to count by here. It might be easier to count by 12s here. So we're going to count, let's do that in this color. This is going to be 12, so 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144. Just because I know where we need to get to, it's easier to count by 12s here. All right, so we have -b, -96 over 2 times a, -96 over -32 gives me 3. So now we're going to plug 3 back in. We get y equals -16 times 3 squared plus 96 times 3. Y equals, and sometimes you are going to have to do this in your head, but you might also be able to do this in some kind of calculator, but just in case, 3 squared is 9. 9 times -16 is -144. 96 times 3, 278, 288 is 288. We add these together and I get y equals 144, which means my vertex is at 3, 144. Remember, this is your seconds, this is your height. So let's plot that. 3, 144. And it's halfway through its trajectory when it gets to its maximum height. So if it took 3 seconds to get to its height, it's going to take another 3 seconds to fall back down. Remember, this is symmetrical. So how long does it take for the ball to reach the ground? It takes a total of 6 seconds. 3 to get to the max height and another 3 to get back down. 6 seconds to reach the ground. The maximum height this time is 144 feet, reached at 3 seconds. So reach that at 3 seconds. Okay. So now, and this next part is what we really need to focus on, because this is what you're also going to be doing for your activity today. We're going to do 2 of these where we're going to graph. We're going to look at this from all different solutions. We're going to do 2 of them, and then you are going to do your own 2. So there's the 3rd page of today's classwork shows you, gives you another sheet to do this on by yourself. So let's look at the first question. What will the shape of the graph be and why? Well, this has a degree of 2, meaning it's a quadratic, meaning it's going to be a parabola. And since A is positive, it's a concave up. So it's a parabola because degree of 2. And it's concave up because A is greater than 0. So we know that. So now we're going to create a table of values for the domains 0, 1, 2, meaning the x's. We're going to plug these x's in, 0, 1, 2, 3, 4, 5, 6, and then generate these y's. I'm okay if you do this in Desmos or you do it in your head. Either way is fine because we have practiced doing this without. So let's do this in Desmos. Remember, always put in parentheses. So 0, we already should know what this is because when we plug in 0, we should get our y-intercept. But just in case, we can always check. So minus 6, 0, plus 5. So we got 5. When we plug in 0, we get 5. So this is your table. Now I'm going to plug in the rest of these. So make sure you have this table written out because I'm not going to go back to this till the table's done. So when we plug in 1, what do we get? We get 0. When we plug in 2, what do we get? We get negative 3. When we plug in 3, what do we get? Negative 4. Guessing the next one's going to be negative 3, but we're going to see. Let's see what happens when we plug in 4. We get negative 3. What happens when we plug in 5? We get 0. And finally, what happens when we plug in 6? We get 5. All right, let us now graph these. So I have 0, 5, 1, 2, 3, 4, 5, 1, 0, 2, negative 3, 3, negative 4, and that is, I'll go back to that in a second. I get 4, negative 3, 5, 0, and 6, 5. And if I look at this, I can find my axis of symmetry. It's right here. I know, I hear you, Dodo. She's getting very worried. That is my axis of symmetry. Make sure you draw your line through your points. All right, so we did our table. The next thing, the 0 solutions, roots. These are the x-intercepts. They're right here. It's at 1 and 5, and you can also see that at the graph because it's when y, or in the table, sorry, it's when y is 0, at 1 and 5. The domain, again, for all parabolas, it goes to the left forever, to the right forever. It's all real numbers. The range is up and down. The lowest this can go is negative 4. It cannot go below negative 4, so y is going to be greater than or equal to negative 4. Looking at the equation, where will the graph cross the y-axis? It crosses the y-axis at 5, and we know that because it's the c, 5, because it is the c or constant. The axis of symmetry is the vertical line that splits the parabola into 2 equal halves. Now that's at x equals 3, and we can double check that by doing negative b over 2a. So first I'm going to identify a, b, and c. So I have 1, negative 6, and 5. And if I do negative b, so negative 6 is 6 over 2 times a, which is 1. 6 divided by 2 is 3. So we also got 3. And the vertex is the highest or lowest point of your parabola. This point will always be in the middle of the parabola. This is why the axis of symmetry is the x-coordinate of our vertex. Plug in the x value from the axis of symmetry in the function to solve for x, or for y, sorry. Or you can just go over to here, because we have x of 3, and it's -4. Now, does this have a minimum or a maximum value? This has a minimum because a is greater than 0. And that's what you're doing today. We're going to do one more together to show all of this. But this is your answer right here. All right. Let's look at the next one. And I'm going to show you something a little bit different in Desmos this time. So what will the shape of the graph be in y? This will also be a parabola. Again, because it has a degree of 2. Now, will this one open up concave up or concave down? This one's going to be concave down because of that right there. Because a is less than 0. Or negative, whichever way you want to say. A is less than 0, meaning it's negative. Let's identify our A, B, and C right now. My A is -1, my B is 3, and my C is -2. So, looking at this equation, where will the graph cross the y-axis? At -2, because it is the constant, or C. You can just write constant, meaning it's the number by itself. That's what it means to be a constant. Now, we can create a table of values for the domains 0, 1, 2, 3, 4, 5, 6, meaning plug those numbers in. Now, I'm going to show you a different way to do this. So what I could also do is I can do the function in here. And instead of putting y equals, I'm going to put f of x equals. So f of x equals -x squared plus 3x minus 2. Now, the easy thing about putting in f of x is that I now can plug numbers in for it. I can either go to the graph and just look, like I have 2, 0, 1.5.25, 1, 0, 0, -2, so I have my y-intercept. But I also can plug all those numbers in that I want to, like I want to plug 0 in here and get my answers. So the first one is -2. So when I plug in 0, I get -2. This is your function notation. When I plug in 1, I get a 0. When I plug in 2, I get 0. And that's perfectly fine. When I plug in 3, I get -2. When I plug in 4, I get -6. When I plug in 5, I get -12. We might not be able to graph all these points. When I plug in 6, I get -20. Now the big thing here, is you have to make sure your function is written correctly. If it's not, you're not going to do this correctly. Okay, what are the zero solutions roots? Let's graph what we have, and then we'll figure that out. So we have 0, -2, 1, 0, 2, 0, 3, -2, 4, -6, 5, -12 will not fit on here. But since there's one here, I can also know there's going to be one right here because that's symmetrical. Now, if you notice, my halfway point is going to be somewhere in between 1 and 2 because that's where they're symmetrical. I'm not quite sure where that's going to be. I can look on my Desmos graph and it'll tell me, and we'll see that, but we're also going to do the math for that. So my zeros are the x-intercepts. They're at 1 and 2, and I can also see that from the table where they're both a 0 there. So it's 1, 2. Remember, domain never changes. This goes left forever. This goes right forever. So the domain is all real numbers. And my range, what's the highest I can go? I have a maximum value. We're not sure where yet. But y is going to be less than or equal to something. We first have to find that vertex. We don't have a point yet to know what it is. So let's first find our axis of symmetry. My axis of symmetry is unknown up here. So it's -b, or -3, over 2 times -1, which is -3 over -2, or a positive 1.5. That's my x for my axis of symmetry. And that's correct because that's halfway between 1 and 2. Now, what I can do is I can go back over here and plug 1.5 in and see what I get. And I get 0.25. 0.25 is my y. So that being said, the highest I can go is 0.25. That is the uppermost point that I can go. Now, the other really cool thing about Desmos is if I click on this line right here, it also tells me that point. It gives a vertex. The main points that Desmos will give you are any intersections or interceptions. So like if you have a system of equations and two lines intersect, it's going to show you those points. It'll show you a vertex, it'll show you x-intercepts, and it's going to show you y-intercepts, because those are all considered important points on a graph. Okay, for your homework today, you are tasked with doing 2 more of these problems. So attached to this assignment is going to be a list of problems. There's about 7 problems. Do not do them all. Just pick any 2. It's up to you which 2 you want to pick. Write the function and answer the same questions that are here. There are 2 of these for you. If for some reason you can't print this out, it's not a big deal. You can either choose to do a graph in Desmos and screenshot it, copy and paste it. You know how to do that. We've done it a couple times. If you don't, always ask me. Or you can just sketch the graph. It doesn't have to be exact. It's up to you. Okay. I hope you have a great day. If you have any questions, please know I'm just a call or Google Meet away. Bye.